Pause the video now, have a go at the question, and press play when you're ready for the solution. So in this question, we want to convert a recurring decimal into a fraction. So first off, I'm going to set my recurring decimal equal to x. I'm going to write it out fully. So 2, 4 recurring means 2, 4, 2, 4, 2, 4. You get the drift all the way to infinity. Okay, and then the method that I use is, this is your recurring part. So I kind of want to isolate the recurring part of your decimal, and I want to get rid of it. So what I'm going to do first is, I'm going to times the whole thing by 10. So I've got 10x on this side, and that will give me 1.242424, etc., etc., over here. And like I say, I want to get rid of this part. So I now think, what is another multiple of 10 that, well, how can I multiply this by another factor of 10 in order to get 242424 isolated? So if I times this by 1,000, so 1,000x is equal to 124.242424, etc. And you can see here, after the decimal point, you've got 242424. After the decimal point, you've got 242424. So what we can do is, if we do 1,000x take away 10x, that will give us 990x. And then, if I do this number, take away that number, the recurring bit just cancels out, which is what I wanted. And then I have 124 take away 1, which is 123. And then here you just rearrange, so x equals 123 over 990.
What about if it says in simplest form?
Oh yeah, that is, yeah, quite right. Right, so they're both divisible by 3, right?
Yeah.
So that's 330. What's this divided by 3? That's 41. Yeah. I knew that.
Right, so there's more than one way you can do this. I'm going to show you a slightly different way, and then you can decide which one you prefer. So start off like Grace did and say that, write down what this number is. The reason for that is that you're showing the person who's marking it that you actually understand the question, which is always a good thing, isn't it? And then what I would do is look at how many digits are repeating. There's 2 digits that are repeating. So I would choose the power of 10 that has 2 zeros in it and multiply by that. And that's going to bring that 1 and 2 across, which gives us this. And then I would look at this and say, well, we can see that from this point onwards, the numbers are the same. So if I subtract this from this, I get 100x minus x is 99x. And then we would have 12.4 minus 0.1 is 12.8. And divide both sides by 99. What am I doing? Yeah. Takes us to this. And now all I've got to do now is tidy this up. So I'll times the top and the bottom by 10 to get rid of the decimal. And now we're in the same place that Grace was a minute ago, just simplifying the fraction. So dividing the top and bottom by 3. If it's on a non-calculator paper, you can see that the top and bottom are divisible by 3 because the digits add up to a multiple of 3 on the top. So, and we end up in the same place. So the main difference between these two methods is that in Grace's method, you made 2 different multiples of x by putting an extra sort of 10 in that you didn't necessarily need, but that simplified the end because you ended up straight here, whereas I only made 1 multiple, but then I had to do a bit of extra work here. So it's basically the same, it just depends at which point you want to do that extra bit of work.